Hi everyone. In this video we're going to be talking about the unit vectors, which are those i's, j's, and k's. Alright, we are going to mark a location for a point on this coordinate system, and we'll mark it at 3, 4, and we'll just call that point A. Okay, now if we make that a displacement vector from the origin to that location, we now end up with vector A, right? Point A was at a position of 3, 4, and once we make it vector A, we know that it's actually going to have a magnitude of 5 at some angle, because it's a 3, 4, 5 triangle. Okay. In this notation here, that's just basically laying out the x and y coordinates. So if I wanted to label AX, it would be a positive 3. If I wanted to label AY, it would be a positive 4. And that would be those coordinates, components of that displacement vector in the x and the y. Right, so that would be AY, that would be AX. And that's all this notation really is. Clumping the x's and y's together as a point. Now, how do we represent the unit vector notation according to what we already know? So vector A in unit vector notation is going to be the value of the x, the magnitude of the x, times the direction of that magnitude, which is in the I direction, plus the magnitude of the y component times the direction of that vector. So each of these are basically a multiplication of a magnitude and another vector with a value of 1. Right? So we're multiplying 3 times 1 in that direction. So if you multiply a scalar times a vector, you end up with a vector. All right? So this vector just happens to have a magnitude of 1. The j has a magnitude of 1. The k has a magnitude of 1. But it just incorporates that direction along the axis. All right, that isn't stated unless we write it this way. So that's all that means. It's basically taking a point notation, understanding that each of these are the components of the vectors that lie on the axis, and that I value is saying that it's in the positive x with a value of 1, and you're multiplying it by the magnitude of that vector. Right? So pretty simple. So if I listed a different vector, vector B, in unit vector notation as negative 1 I plus 3 J. Where that point would be on our x and y axis is we would go over in the x, negative 1, and go up 3. So we'd end up with a point at that location. So our vector would look like this from the origin, and that would be vector B. And the x component drawn in would just go to negative 1, the y component to 3. So if a question asks you to find the resultant of B written in unit vector notation, this would be what the answer is. Okay, so that's really the resultant of B in unit vector form. If we want to solve for the resultant in, I think it's just Cartesian coordinate form, what we'd have to do is what we've done last year in honors, which is just use the Pythag. Okay, so to figure out the magnitude of B, you would do the Pythagorean theorem on the magnitudes. So there you go. The resultant of B would be the square root of 10 plus, we would have to figure out the angle. And we know we use the tangent function, and it's always going to be the y over the x. So here we have 3 over -1, where we actually get an angle of -71. Right. Now, I just wanted to go through this example because when we list vector b in that form, whatever the square root of 10 would be, we'd have to list that at the angle that it's pointing to. From doing that, we get the -71. Now, that's not pointing at -71. -71 would be down here. Right? So what direction is that vector actually pointing? We have to figure out that angle with respect to 0. Right? Or we can look at it this way and subtract 71 from 180. Okay, so we get 109, right? So that would be the direction for that vector. Alright, so this is the resultant in unit vector form. This is the resultant in, I think, Cartesian or polar coordinate form. Can't remember the term there. All right. This is what we're used to from last year. So this is the new stuff. It's actually a lot easier, all right, as long as you grasp the concept of what the unit vector actually is. Now, what happens when we have to add these vectors together? All right. Vector A is going to be 3i minus 2j. Vector B is going to be -1i minus 2j. So what that looks like on the graph is vector A is going to be at 3 and -2. And then B is going to be 1 to the left of that, okay, because we're going to add it on. Actually, let me draw the vector, the full vector here. Now we're going to go to the left 1 and then down 2 more, because that would be -1 and -2. Okay. So what's the resultant going to be of the addition of A and B? So it's going to go from here to here. So we want A plus B in unit vector form. Now this is super simple. And let's look at the final answer first from the graph. So where is this point? That point is going to be 2 over and 4 down. So the answer for A plus B is 2i minus 4j. And we can look at that from the graph. How do we get that? Let's just add up A and B. So we have 3i minus 2j minus 1i minus 2j. And we just do the math. We can add i's to i's just like we can add x, only add x's to each other. So 3 minus 1 is 2i, -2 and -2 is -4j. So when we add vectors in unit vector form, super easy. It's way easier if we're given vectors in a polar form. The form that we used last year is a polar format, which looks like that. So they're given the magnitude and the direction of the vector instead of the actual locations. So I'm going to go over that in the next video.